event. This is the Internet Governance Project at Georgia Tech, and we are today discussing a very interesting issue of it's fundamental to Internet governance, and that is, of course, the Internet has succeeded because it created global compatibility among data communications at a critical time in the evolution of information technology in the early 80s, when we were just getting LANs and personal computers, and the process of networking was being democratized, and the Internet protocols succeeded in creating an unprecedented degree of openness and participation in global networking. But that was a very long time ago. That was more than, about 40 years now almost. And in that time, we've seen 4 generations of mobile communications, telecommunications technology. We've seen massive upgrades in computer capability. And at the same time, we've seen an attempt to improve and upgrade the Internet standard, namely IPv6, which has had a gradual and very slow diffusion. So we're here today. We have 2 distinguished experts in basic networking protocols. We have Dr. Richard Lee of FutureWay Technologies. He's in California. And we have Andrew Sullivan, who is the president and CEO of the Internet Society. And we will have basically 4 parts to our discussion today. First, we're going to discuss what the problem is, whether we need new IP or not. Then we're going to discuss some technical details about the differences in protocols and architectures. And we're going to talk about standardization venues. And finally, we're going to talk about the impact of these initiatives on global Internet governance generally. Now, in terms of questions, we would like to go through those 4 parts of the discussion first and then open it up to questions. If you want to ask a question, then please indicate that in the chat. I don't think we have a hand raised function in BlueJeans events. And my colleague Brendan Kurbis, who's one of the principals at the Internet Governance Project here at Georgia Tech, will try to keep track of who wants to ask a question, and we will upgrade you and invite you to turn on your microphone when that time comes. So let's get started. Richard, why do we need the new IP? What problem does it solve? What makes current upgrades that have been happening at the IETF for 20 years, what makes those inadequate? And what's the point behind this whole initiative?
Hello, everyone. Hello, Milton, Andrew, and I'm Richard Lee. I'm delighted to be here. And it's a huge question, and because the answer is not that simple, because we worked on this since 2015, already 5 years work, and we started to publish in 2017. Okay, so everybody knows that, and I totally agree, not deny. Internet is a very successful technology, and perhaps the most successful technology ever invented over our times. It has created millions of jobs and billions of dollars of business, and we are benefit from it. And it looks like that. At least I believe it's an engine of current and temporary economic growth. But not everybody, every sector benefits from the success of the Internet. The success of the Internet looks limited to the information technology, communication technology, also called ICT. There are still many other networks and applications that have not been connected to the Internet yet. For example, operational technology, or OT. OT is different from ICT in the sense that the information exchange between 2 points need to be done under certain KPI requirements. KPI is typically used in some communication technology like latency, packet loss, throughput, and a few others. And for some OT, they normally talk about dependability, like reliability, availability, integrity, maintainability, and security. So, like latency, packet loss are part of it. So when you send a control, for example, in factory, when you send a control command, let's say to stop a robot, if the command is too late, the robot may do some harm to its environment. There are some examples. So especially in 3GPP, there are extensive technical specifications and technical reports on that. So KPI metrics such as latency and packet loss ratio must be guaranteed for OT networks, right? But currently, OT networks and applications and devices and protocols, it appears that right now they are in roughly the same state of development and deployment that IT was in the 1990s. There were 10 to 20 industrial protocols in use, and none of them is dominating the market. And some of them are not even digitized. They are still using analog signals, not digitized. The biggest market share is even less than 15%. Maybe it has been changed. I have not followed up. At least as of last year, the biggest market share is 15%. And there are about 10 protocols here in use, and mostly are proprietary or in one sector, right? So in order to expand the internet, I mean the scope of the internet, so that we want to converge IT, CT, and OT. And so that's we need to see if the current IP works or not. So we did some research and some experiment. We found that current IP is not capable of meeting the KPI requirements. So that is a problem we want to solve. So we want the internet to be a truly pervasive and ubiquitous network that will converge all the IT, CT, and OT together. So that is the first problem we want to solve.
Okay, good. Richard, let me invite Andrew to come in now and respond to that. So I hear you saying that fundamentally you're concerned about OT and IT convergence, and that there are simply networks and applications that really don't work well or won't work well going forward. So Andrew, what do you have to say about that?
Thanks first of all for hosting this. The thing that I would say about it is that we're sometimes confusing some layers here. So this isn't really just IP that we're talking about, but actually a whole suite of protocols with IP kind of in the core of it, because IP is pretty thin, right? But I understand why that shorthand is being used. So, like, that's really a rhetorical point rather than a serious technical point. The deeper question is whether these are really internet applications or not, because that's actually part of the question. The basic idea here is that we're looking for convergence, and one of the questions is whether people actually want to converge. Some of the applications that we're talking about are designed not to use the internet on purpose, right? They're avoiding internet communications because they're deeply conservative industrial sectors that want to avoid that kind of environment. And so it's not clear really whether the demand is there, whether this convergence is something that people really want to do, or whether that is something that is really valuable from the point of view of the users of the technologies. Now, then we have the question of, what the use cases are where the users of that technology really do want that convergence. And then the question is exactly as Richard laid out, I think, what are the constraints for those use cases? And I think there's no question that we've seen cases where the traditional network stack that built the internet doesn't work very well. The obvious example of this is interplanetary networks, where we've actually developed, a whole alternative sort of mechanism for those communications, involving delay and disruption tolerance, because if a moon gets in the way, then your signal goes away, and so you've got to have a mechanism to recover that. So that's a great example of where a bunch of research had to happen in order to understand, okay, here we've got these use cases. The traditional IP stack doesn't work for us, so what are we going to do instead? And I think that it's entirely appropriate that if we've got these very specific use cases, we try to work on what the gaps are, what is the analysis that needs to be done in order to understand what problems it is we're trying to solve, and then we're in a position to decide, hey, is this really an extension of internet protocols? Is this a new kind of protocol that needs to be built up, an entire new stack? Do we need a new generation, or what? And I think that gap analysis is actually one of the things that is perhaps one of the biggest issues that we really need to confront in order to decide what the right approach is.
Very interesting. So, Richard, in some ways, he's suggesting that the whole idea of calling this a new IP was maybe a bit of a mistake or an overreach, or do you think we really need to talk about a new IP or sort of a migration to a new generation, or are you talking more about a niche development of protocols more suited to OT/IT?
Okay, so first, short answer to yours, and whether it should be called next generation or not, that's not super important question actually. Just the name, actually, I really do not care. But going back to Andrew's and comments and opinions, actually, I kind of agree with him, but I like to add some, give some follow-up. So I'm hearing that from what Andrew said, which I agree. Actually, there are two problems or issues here, and as correctly analyzed by him. The first is that, do we want to converge DT and internet or not, right? So that's my understanding. Assuming we want, can we do it with the internet or not? If we want to do it, how can we do it, right? So these are two questions here. The first question, do we want it? It's not going to be decided by me or somebody else, but it appeals to me because from especially in 3GPP, I don't remember that number, a technical report and or technical specifications, they really want to empower the OT domain there. But what they do is that only in a very small segment of the network, there is a radio access network. But we know that radio access network, and that in order to make it work, you need to connect the base station, or so-called G node B or GNB, to the core network. So this part, actually, right now, carriers and service providers are using internet. So in 4G, MPLS VPN is widely used to connect the base station and the core network here. So if we change the topic, let's say how we expand or improve how to make that part to support such requirements that are agreed in the industry and in 3GPP body. So how can we do it? So here I agree with Andrew. Here we have two questions. The first is, do we really want internet to be a convergence technology for ICT and OT? If we want it, how can we do it? So the new IP here actually is already made an assumption. Suppose we want it, and then how can we do it? That's my follow-up to Andrew's comments.
Andrew, do you have any immediate response to that, or should we move on to the?
Well, I think I do, but I think it actually will bridge us to the next topic anyway. So so let me say this: if the basic idea here is, okay, suppose that we want this, how do we do it? I think the problem that I keep struggling with a little bit is what the value of this is. That is, sometimes what we want, like the 3GPP example is a good one. Oh, you've got this sort of link in this access network, and that's one style of networking, and then basically you connect, in the next hop with the internet. If the idea is we need to replace that next hop with vertical integrated system of some kind, then what that is really a discussion about replacing the existing internet with a new network, maybe running them alongside each other and then eventually cutting over to it. On the other hand, if what we're talking about is very specialized network use cases that then are going to be interconnected to one another, well, that's just the internet, right? It's a network that has particular local kinds of things, and then you've got a network at the other end, and you want to interconnect them in some way. And that's actually, I mean, we had those. We've had other kinds of networks like that, and every time IP wins in those use cases. And that suggests that IP has certain properties for that kind of interconnection model that is particularly good. And that the internet style of interconnecting in this case is particularly useful for that. So I think that this is one of these cases where we really need to be quite clear about what gap it is we think we're filling. And I feel like maybe the biggest problem that people are having in some of this discussion is that they don't know which engineering problem we're tackling. This is an engineering problem. It's a question of like what the trade-offs are going to be. Much more than it starts as a governance problem. It starts as an engineering problem. It maybe has governance consequences, but the first thing we have to decide is, hey, what is the engineering problem that we're trying to tackle? Because if the problem is a very specific gap, then we can figure out how to fix that. Whereas if what this is a gap that involves something involving replacing, very low level layer 3 or something like that protocols on the internet, it's a bigger deal because that's all new silicon, it's all new routers, everybody's got to replace all, get all new equipment, and some of that stuff hasn't been invented yet. It's very easy to have the great features in the thing that hasn't been invented yet and compare that to the sort of nasty, tatty old version that you've got that's actually deployed, because the future thing is always hasn't been invented yet.
Well, then let's move on to the more technical elements of this. So Richard, how developed is the proposal? I know one of the things that frustrated me when I saw some media coverage of this new IP idea was that people were talking as if this were a fully developed protocol that China wanted to use to completely change the internet. And then on the other hand, I heard you and other people say, well, this is just a research idea. So what is going on here? Is this an architecture or is it a protocol? What are some of the key technical areas where change should or should not be made?
Okay, so it's also a huge question. But first, I would like to say, don't trust media. Right? So media, lots of misinformation and disinformation there. And it's quite misleading. And it's so unfortunate people even make a decision and influenced from the media. For example, one good friend, and he actually holds a very high, very senior position in Cisco. The one day he called me, talked to me about that. Said, don't that. Look at the technical publications. There are tons of publications there, and it's starting 2017, and started to publish that. So technically, so especially inside EDC is another SDO. They know that, and here it's the reason we solve the problem. So the reason the OT ICT convergence is one of the problems we want to solve. Right, we want to maintain the integrity of the internet, consider the internet as one network, maybe global one, and of many different network cells. And so we want to add or enrich, enhance, and the functionalities of the current IP. So Andrew made a good point like earlier said that where is the gap here, right? So we found the gap, and then we want to add it and fend it so that it's an extension of new IP or improve the new IP or now or generically we call that new IP can solve those problems there. So all the solutions are based on the current IP, IPv4 or IPv6 actually, both of them. So we extend it and we add more functionalities or features as a data plan, and it's called data plan, right? You have a control plan, you have the data plan. We add those to there so that later your switch and router can be implemented to support those capabilities, new capabilities or services, so that CT and ICT will be fully convergent. So, you asked me about technical detail. Do you want to talk about the real format, or just what the packet really looks like, or what, right? So what we do here, right? So just think about this, right? When the internet was this kind of work was done, it's inside the IFIP in 1960s, right? So that time a packet is not called a packet. Actually, it was called ladlegram. Ladle is I send you a ladle, right? And sometimes we mail, right? So we are using a post office. So an IP packet or technology and simulates mail system. So a mail, you have an envelope and you have ladle inside. So the ladle inside becomes a payload, and the envelope later becomes a header. So if you look at the IP packet, it has two portions. One is a header, another is a payload. Payload is usually unstructured, so it's just some opaque data, and the router should not know about it. The header and the routers could make sense of it. Over so many years, similarly in courier services, right now we know that FedEx, right? What's the difference between FedEx and a classical mail here? So a FedEx can guarantee something. Let's say I want to have 24 hours overnight shipment. So today I send a FedEx package. So next morning, my package will be somewhere. Of course, it will be subject to some physical constraints. You cannot ask for anything. For example, send my package to Santa. Let's say some children actually did this, right? So send my package to mom. So simply you cannot. Suppose you can, and then FedEx will do that. So if we compare FedEx package and the mail system, so the FedEx package has one more paper, that's a slip or something. So the user or sender actually write down your requirements, says that, okay, I want this package, 24 hours shipment, 3-day shipment, or 1 week shipment, right? It doesn't matter. So this information is so critical for operation of FedEx system. So FedEx will deliver your package not only according to your destination, that's a receiver's address, and also this FedEx slip. So in new IP here, we add one component. So the component is a simulation of such a FedEx slip. Say that, okay, in addition, let's say I want to send a packet from California to Andrew's home. So I put Andrew's as my destination. In addition, because it's so important, I want next day, next morning, deliver it. So we give that package to FedEx. So in this sense, new IP is a simulation of FedEx, and IPv4, v6 is a simulation of the classical mail, post office mail system. So that's about the CT and ICT. So if you do this, and a new IP or extended IP, improved IP, will have new capabilities, and it can do more, just not only connectivity and delivery, it can also support new capabilities, and so that we can deliver under some requirements. These requirements coming from the sender or user.
So it's the old QoS, is it? I've heard, I mean, is that what you mean by deterministic forwarding?
Deterministic forwarding, and it's a terminology used in IETF, and it's in Internet there. It's partly, it is. So in new IP, actually, it goes beyond that. We call that high precision communication. The reason we want to call it a high precision communication, we have other reasons. And do you want me to talk about it?
Well, I don't want to get too technical here, but I think the main question, which I'm not sure you're answering, is all this worked out? Is this all developed? Have you defined it?
It's we have initially we did the research gap analysis. That was a few years ago, and we did a conceptual research. We did experimental research, some testing. I also did some mathematical physical analysis. And it's for majority of it is done, and it looks that the idea is solid, viable, and feasible in implementation. So, and starting from this year, we are in the beginning of that. We want to open up this technology. We want to share it with the public, and also possibly it's like a standardization, because we believe that open standards and make standards open is a key to let internet to be successful. So we want to be a stakeholder and participation. Actually, it has happened. So initially, it was a really small project. So right now, it's fairly big, and many countries, many especially universities, and they have joined it. They did the independent research, prototyping, they published their publications. Also, there were some dedicated conferences on those. So as I said that, so new IP, just imagine if you don't like new IP, this comes not next generation IP, call it FedEx IP. Okay, that might be simpler. FedEx IP, older IP or not older, IPv4, V6 called a US, USPO IP, right? If you want it.
All right, Andrew, Mr. Old IP, do you want to comment on some element of that?
Well, I think I really like analogies. I think that analogies are extraordinarily helpful to understand most of the things that we, that are new inventions and so on, because really you need to understand the unknown with things that you already know, and so analogies are very helpful. But I think that this particular analogy is really clever, but it has some, it's a little misleading. So one of the features of the internet is that it isn't actually one network, right? It's multiple networks. It's an internet. And what that means is that the different networks have different properties in them. Now, this is a place in which the postal analogy actually helps us, because one of the features of the postal system is that it's a cost-fixed system with a standardized format, and that standardized format is delivered everywhere for generally the same price. So you've got sort of standard postal mail, and you put a stamp on the outside, and as long as it's within the service area of that postal system, it's a flat rate. One of the features of FedEx, of course, is that it doesn't actually go everywhere, and there are lots of places where they say they simply will not deliver these things, and it's really a negotiation between you. Moreover, the user in this case has to make decisions about this. So the other piece about IP, and the reason that we keep falling into the idea that the internet is one network, is because that's the user experience of the internet. The user experience of the internet is that it's all this big flat space and it's all just network services for you. If you have to make a choice, if you have to think about what are my use cases for this datagram or this packet that I'm going to send, you then have to go to, the post office or the FedEx office, or you've got to go to a box on the street and see whether the little green sign is there to tell you whether today's collection has happened. And those are all things that are forced as part of the user's experience of this. So if what we have to do is tell applications, hey, you have to start thinking about what the needs are for your low-level traffic in order to make a decision about which kind of network you're going to use, well, it's not clear actually that this is IP in any sense at all then, because it moves that decision about which network you've got to use in order to get the guarantees that you want out to the edge. But that, to come back to the original thing, that is precisely what the internet originally did. If you go back to read the end-to-end arguments paper, one of the things that's interesting about it is that people talk about this as though it's machines, end-to-end, the machines are doing this. But actually, the end-to-end arguments paper doesn't talk about that. It talks about the applications. Applications do not have to live on a single machine. And so the reality about this is that the endpoint in this is the intelligence of the application trying to make a decision about what kinds of properties it needs from the network. And what that means is you want to strip out as much intelligence as possible from the low-level network protocols, because you got to implement them in the application anyway. And if that's the case, then all you really need here is a layer 3 model that just delivers a very simple sort of, I promise to get it there within this time, a deterministic networking model, and really not much more to it. And under those circumstances, we're back to the internet model. Because in that case, the application needs to make the decisions. And all of this stuff about how the router is going to do these things and all the rest of it is really a distraction, because it's a question of what kind of properties the network that you're connected to is going to provide, rather than what kind of properties the internet is going to provide. The internet remains the best efforts networking in order to deliver this kind of thing with this smooth end-to-end property. And what you've got to then have is another level of service in some sense in order to build that up. But the application needs to know what kinds of decisions it needs to make in order to use that kind of functionality. And that to me is a little bit different from the proposals that we've seen so far, because many of the proposals that I've read anyway seem to be pushing some of those decisions down into the network. They're providing sort of network services that give these kinds of guarantees. And that's not a very internet-like thing. And that's actually a conceptual difference between these two models. That is, FedEx not only... Oh, sorry, go ahead.
That's very fundamental, this issue. I'd like to hang on this for a bit.
Sure.
The end-to-end argument. And I have seen in some discussions I've had with Huawei engineers some criticism of the end-to-end model. And maybe, Richard, are you departing from that? And I think Andrew makes a very strong case for a separation of the layers here between the networking layer and the application layer. So are you challenging that? You think we need to move beyond that?
Yeah, it's okay. Let me comment on that. So that's where we start to have difference here, right? So what Andrew said is right with respect to what internet is or what internet was. So internet was designed best effort that globally used, right? That was true, and that continues to be true. I'm not changing that. But think about this. Internet is a system to deliver information from A to B, right? So it's called a delivery system. And FedEx IP or FedEx is another type of delivery system. Post office mail is a delivery system. FedEx, like a service office, is another delivery system. But can we consider them as in a more generic senses, like it's a still delivery system? So in that case, so my point is that we should expand the scope of internet to cover other things. For example, right now in post office, they also provided some guaranteed services, almost the exact same way as FedEx does. But then maybe there are some differences right there. So here, my point is that we need to expand the scope of the internet in order to serve the economy industry. After all, why do we need to do this? We want to do something like to make our economy grow. So that's I said that it's my belief that internet right now is the engine for the economic growth. Look at the Wall Street, those companies, right? All the internet-related companies, their business is good, right? So it's an engine. So I want to add more gas, more fuel to this engine here. So that is saying, generally, and that's for that. So I partly agree with Andrew with respect to the classical post office. So that's how internet was defined. But what we are doing is that we are expanding the scope of internet. Just actually last year in I gave a keynote speech in GlobeCon. I told them that so come the internet, actually there's a limit. We want to go beyond that limit to cover more cases. So come back to a question and asked by Milton and saying that layers here, layers application layer and network layer. It's true, and we have layers here, which I agree that's obviously internet model defines that. So typically you have 5 layers here. You have the top is the application, like a news, mail, right? And then under that, you have end-to-end model. That's typically TCP, UDP, quick. And then you have a network layer, that's hop-to-hop. And then you have a link layer, typically Ethernet, gigabit Ethernet, and then optical, physical layer, right? So you have 5 layers here. Each layer is like divided. They have special functions. And for the best effort internet, it works well. So because I have a TCP here, that's fine. So if you want guarantee when the packet sooner or later gets there, use TCP. If you don't care if your packet is lost or not, use UDP, that's fine. But when we say, suppose I want to solve the problems I described earlier, like guarantee something, and then we found that here, wait a second, like if let's say I use TCP here to deliver my message, suppose my packet is lost somewhere, somehow, and then TCP people say that, okay, simple, I retransmit. But let's do a math here. When you retransmit your packet, your latency is not just simply double, actually it's a triple, right? Because why? After you send a packet, you start a timer. That time is called a retransmission timer. The retransmit timer is roughly the same as a round trip time. So from A to B, from B to A. So during this time, you have not received the acknowledgement. Okay, let's retransmit it. So you send a packet from A to B again. So that's triple. But in some industrial applications, yes, I get your packet, but sorry, that's too late. So here, using the transporter to deliver something here. So all my point is that we solve the industrial problems at the application layer, at the transport layer, and it's not simply possible. This can be mathematically proven, right? So how can we solve it? We have to take a look at the network layer. So at the hop-to-hop layer, we solve it. So that's why we are working on network layer to improve the IP packet to instead of like improving like TCP, UDP, transport layer, it's not.
Very interesting. Yeah. You want to jump in, Andrew? We're going to have to move on to the next item, though, after.
Well, but I think that this highlights a point that is related, I think, to other parts of our conversation. It's very slippery which thing we're talking about here. If we're talking about specialized network use cases where somebody really needs these kinds of guarantees, then it may well be the case that you've got to have a new network technology for that because you're trying to ask for guarantees that TCP cannot provide. I'm not totally convinced that that's the case, but there's an engineering question there. That's very different from saying we want the internet to be upgraded to that kind of thing. Because when I have those very tight connectivity requirements and so on, I've already got a situation where the applications are involved in this and so on. So it's not actually a general purpose technology in that case, in the way that IP and TCP/IP and QUIC and all the rest of it are intended to be. And you've got to make that we've got to make that distinction, whether that's the kind of problem we're talking about or whether we're talking about all kinds of other stuff. The other question then is actually a sort of, it really is more of a governance question, which is whether we're going to pack all of these other requirements into the lower layers and thereby make the fundamental technologies of the network have to provide these kinds of services to everybody, because that makes for a very, it makes for a complete replacement of essentially all of the hardware on the internet that we've got deployed today. The last time we managed to do a forklift upgrade on the internet was 1983, so I don't think it's very likely that we're going to be able to do that that quickly. And so at some point, we're going to have some way in which this comes together with the existing IP layer. And at that point, all of the TCP/IP questions come right back into play anyway. So it doesn't seem to me that we're being totally clear about this, like which side of this line we're living on. If this is just control networks, industrial networks, that kind of thing, then that's one set of problems. But they're a constrained set.
Short follow up, if you allow me.
Okay, quickly.
Okay, yeah, quickly. So and actually, Andrew still brings the point up going back. Should like internet covers and OT or not? And you also mentioned general purpose network here, right? And yes, current internet is general purpose, but general purpose has another synonym. For me, that is minimal common purpose communication. So what the internet solves right now, for me, it's a minimal common purpose line. So it's still depends on do you want to expand the scope or not? So for me, we should expand the scope. So not only serving minimal common purpose applications, we should also serve some other purposes, other application. They may not be common purpose, but they are still in our society, in our industry, and so that the internet will really serve them. Because if we don't want to serve them, they will be forgotten. They will be isolated. They are not going to benefit from the success. They are not going to share the success of internet. Internet has a wealth of technology. We do not want another part of the society waste their own time, develop their own network scale. For me, I want to maintain integrity of the internet as earlier I said that. So I want such networks. Part of it. Actually, there are so many such networks. Currently, they are isolated. They are not part of the internet. So I want those networks part of it. So that's a start from the that's a different hill. It's as we discussed earlier. Should we do it or not? Should that be included or not? If they are not included, if let's say okay, let's make decision, we should exclude them, and then there will be no discussion. If you say, okay, we need to include them, and then we have more discussion, that we're more technical, or it's an engineering problem, or protocol problem, or technical problem, software problem, and or it's a chip problem, or or other things, right? So yeah, that's a quick follow up. Sorry.
Okay, that's I think that's one of the fundamental issues that we've identified is this layering and whether we're breaking or changing that model. But we need to move on. I think another question that is really interesting about this is the question of the venue in which these standardization decisions would get worked out. So it looks to much of the world as if Huawei has gone to the ITU as the primary standards organization, although I do know that they did approach the IETF. And there's another option, of course, and that is that Huawei would simply develop this as a standard on its own and start selling equipment in the marketplace and perhaps eventually become a de facto standard or an accepted standard by many people in the industry based on market decisions. And this really matters. I mean, most of the crowd you're talking to here, Richard, are probably pretty fond of and familiar with the internet institutions, the regional internet registries, the ICANN, the IETF, and they're comfortable in that environment. And there are many good things about that environment. It's sort of its openness and its individualism, if you will, not based on states or on corporations. So what, is the proper venue for pursuing this pretty systematic change or upgrade in the internet protocols?
Well, the question, I suppose, for me, is that right?
Both of you will take a crack at it, definitely.
All right. So, okay. So for me, right, ITU IETF, 3GPP, HC. They have different like participants with different expertise coming from different places. So each SDO has its own strengths. For me, it appears that all the SDOs should collaborate because they have different strengths. So, and in this particular case, maybe I'm wrong, like Anu is an expert also who's a very strong leadership position there, maybe have different opinion, but that's my opinion. So in the case of new IP, it's best to let the ITU works on vision, use cases, requirements, and architecture, maybe roadmap. The reason I say so is that so far I have never seen an IFC or some leadership guys there talking about the IETF like a vision, future roadmap. So in which year they do which year. What they do is that it's like a bottom up, just those like a leadership sit there, wait for other guys to propose something. If something makes sense, okay, do it, right? So it's another way. So ITU, they collect all the opinions, requirements, right? So let them do it. But for the protocol itself, we should let IETF to standardize new IP. This is my belief, and actually we also put it in action. So probably you already know that. So that's just one story. Some people, when like in ITU, they publish something. Actually, people don't know another story, and I can share. Actually, I'm personally already presented new IP and in IAB, that's the Internet Architecture Board, and I have organized 3-side meetings. Moreover, something I don't think people know that last year and early last year, we saw that. So we should, because that's my belief that we should make standards open, let the IETF to be the owner and home for new IP. So last year, we think that there was a decision Huawei will sponsor an IETF in Vancouver meeting. I think that's IETF 107. And I was supposed to talk about new IP on Thursday. Normally Thursday, we have a Thursday brown bag lunch beach sale. So so for that one, I want the people think about that. Maybe okay, I know that because I'm going IETF many times. I know it very well. Right? So the mentality is still information technology mentality. Me too. I was converted. So I was an IT guy. Only since 2015, I started to convert myself to some OT industry guy. Right? So change the mentality, tell them what the problem is. And after Vancouver meeting, we started to do that. Actually, we have done that. So that's what I'm thinking. So we should let IETF do the protocol standardization. And so another Milton has mentioned that Huawei say it's just make something, sell the product to the customer. It's a defect to them. Actually, it's untrue. And from the beginning, we invited multiple stakeholders, including customers, some competitors, and also the academia researchers, right? And some people joined it independently, through the international open conferences. So that's not true. But look at right now, there are only 4 incumbent vendors, right? And here, so I mean major big ones there. So other vendors are not even thinking about a long future. Actually, I talked with Juniper Engineering and CTO, and he also visited me in my office, right? So we talked about that. They also shared about that. I also talked with some Cisco fellows, right? So that's told me that for them, if the 2 years, if some project some work is for 2 years, for them it's only long term, right? So what they do is roadmap for this year, roadmap for next year. So this work looks like 5 or maybe 10, maybe 15, right? It's a long way to go. So they are not interested, but they watch, read it, and then sometimes we have casual meetings to discuss and on it. They know what we are doing, and it's fully open to them. So that's a question. That's a short clarification to Milton's already said that Huawei wants just to. That's not true. Actually, we want it to open. So coming back to the venue here.
Just a correction, Richard. I didn't say that you were doing that. I said that that could be done. That's a perfectly viable path forward that some vendor might want to develop their own standard, see if it flies.
Yeah, that could do, but I don't think that that's the right way because success of the internet depends on everyone, everywhere, every sector, right? We should participate, contribute your idea, right? Because as like Andrew earlier said, internet of really a networks, but who does the networks here? Who owns it? Who makes the boxes? Who is using it? Everybody. It should be open, multi-stakeholder. So everybody should join. So we have an open policy here. Come back to the venue here. So for me, certainly I hope IETF will standardize it. But the problem, it's intriguing here is that should IETF, is IETF willing to do it or not, right? So I have talked with people, I heard something oh, Richard, we are already so busy, so maybe 5-10 years, we are not going to consider any other protocol except IPv6. We are getting deeply worried. So IPv6 is already 25 years. Market share probably 20% or even less. Some people told me, one guy told me that 40%, but no matter what, it's still a small market share. They don't see the light in the tunnel. So that's sort of that. If your new IP gets standardized, we are having 3 protocols here. It's not going to be manageable, right? So can you wait for another 10 years until IPv6 gets a full replacement of IPv4? I can wait. Okay, in 10 years maybe I have already retired, right? That's fine. That's okay. The industry does not. The reason is that, so you know that you mentioned 5G earlier. So 5G is going to enable some applications in next 2 or 3 years, probably until 2023, latest 2025. So the deployment probably is everywhere. And then people will develop these new applications. So after new applications are developed, they like to hook them to the internet. But the internet is not ready for them. So currently in EDC, in other parts, they already clearly told me that, okay, if Richard, that time I work with EDC, there's a group called NGP. So if we don't have technology, we are going to solve it in architecture. In architecture, they are solving it by using MEC, that's a MEC, mobile edge computing. Why? They say that, okay, since nothing is guaranteed, let me put my data, my application closer to the base station. The closest port is same place as the base station. You see that the MEC is proliferating. Why? Think about it. Suppose IP can solve it, internet can solve it, and then we do not need to do so. So the architecture of 5G will be the same as 4G. Right now, it's different. Partly the reason is that the fixed line technology cannot catch up with the CT technology there. Of course, so that's why I want to expand the scope from minimal common purpose application to a wider purpose and application.
Okay, we're going to have to. We're approaching an hour now. I want to let Andrew respond to this, and then we need to try to open it up to questions and talk about some of the broader governance implications as well. So, Andrew?
So thanks. I think that sometimes the way that this issue is being discussed is as a sort of venue wars. Should this be in the IETF? Should this be in the ITU? Whatever. And I know that there are people who are very concerned about that, about the politics of that. And I sometimes worry about it because, of course, the ITU is ultimately a government's only venue, and I'm not sure that national governments are really the best place to design our future networked world. But there's another more fundamental issue here, and this has to do with this idea about whether you need a full architecture or whether what you need is to build pieces that can be reused and interlock with one another in new and interesting ways. My view is that the building block architecture is a better one. And the reason I think that is, in fact, a piece of architectural document that the Internet Architecture Board produced some while ago. It's RFC 5218, which asks about what makes a successful protocol. And one of the most important things that they discover in that document, I was not on the IAB when this was written. One of the most important things that they discovered was that the incremental deployability of a protocol is super important to its success. And in fact, IPv6 is a great example of this issue. It's not incrementally deployable because it's formally incompatible with IPv4. And so you basically got to stand both things up at the same time. But the properties of that kind of protocol have a huge resistance to deployment because there's basically no reason to deploy it unless you absolutely need it. And in the case of IPv6, nobody absolutely needed it until we ran out of IPv4 addresses. That is why big architectures tend not to be preferred in the IETF environment. Not because people have an allergy to it or because the IETF doesn't want to work on big architectures or something like that. It's because if you build the big architecture and then you decide, oh, now we got to deploy this everywhere, what you're really talking about is a global replacement of a deployed system, and that's very, very hard to do. So the question here is, I think it's interesting to talk about whether the ITU or the IETF is a better place to talk about architectures. But I think before we get to that thing, we should ask ourselves whether we need a global replacement architecture for the internet. Because if that's what we're saying, well, I think that's an interesting research project, but I don't think it's an engineering problem at all. I think the answer for that is it's never going to get deployed because nobody has the incentives to be the first mover there. It's enormously expensive and it doesn't have the incremental advantages, so you never make any revenue on the first day. That's the real problem for people who are trying to build a business. How do they keep the thing running while they're deploying? And I think that that's a really difficult case. And that's why if these are specialized networks, it's a different story, because specialized networks, of course, do have these properties of needing to build this thing out for just this particular use case. And we see that over and over again. In any case, I could go on about that for a long time, but rather than doing that, I'll turn this over to questions.
So, Andy asked a very big question. Can I answer it?
Very quickly.
Well, okay. So, Andrew said, are we going to replace, to have a global replacement? The short answer is no. And are we working to change the architecture? The short answer is no. So the reason we call that new IP, actually, many years ago, we talked with BT, and they helped me to work on something stay within the kind of framework architecture. We are not, so new IP fit exactly in the current internet and architecture framework. And then incremental deployability, actually, I fully agree with Andrew here. So I'm glad that he mentioned this because I have been asked question about compatibility. Actually, compatibility usually is a backward compatibility. A better name is interoperability. And for the new things there, so it's an even better one. It's a incremental deployability. Actually, we are following that. I'm glad he mentioned that. So from what we are working on, and also customer here, right now, as I said earlier, it's keep the internet or internet technology catch up with the communication technology, especially in 3GPP here. So there are 2 or 3 examples here. One is for the factory. In a factory, normally you have a floor, building, and building here. So that's not always Wi-Fi or wireless, right? So you need some line there. So that's an enterprise network. You can deploy new IP here. Actually, I have a fairly big customer for that, right? So last year they give us some requirement. So that's one deployment. I also mentioned that we need some fixed line technology between G node B and core network or MEC network here. So currently, this fixed line network is part of the internet. IP and MPLS and it's deployed. So what new IP does is not going to replace them, is to reuse them, not replacement, it's reuse them so that this part of network has more capabilities. more functions, more services, so that we can support the upcoming services. So that's initially an deployment will test, and this like a deployment in these scenarios happen to be in the current internet architecture. Nothing's changed. So it's not, UIP is not looking for global replacement, not at all.
Okay, so let's try to move on to questions then. So Brendan, we're going to try to upgrade people who want to ask a question, and then they will ask their question in a very concise manner, or I will mute them, mercilessly mute them. So indicate your willingness to ask a question and its general subject matter in the chat, and then if you want to speak, Brendan, we'll upgrade you.
And Milton, I also collected a couple of questions in the chat while you guys were discussing
Okay, do you want to
issues.
Let's just
sure.
read those off then.
Sure. So here's a question from Laura Denardis. Why are critical applications which have been using TCP/IP for decades, often in combination with SLAs from network operators, now being called over-the-top applications? He's interested in the rationale for this linguistic turn to describe the same thing.
Okay, which one of you wants to handle that? Andrew or Richard? Andrew.
I'm happy to look. Let's be perfectly honest with ourselves. Over the top was a way of describing certain kinds of network protocols that came from a regulatory environment where there was this traditional approach of regulating the network service, and it's an attempt to make the network service, and to apply that to the internet and say that the network service is still regulated. So that's the origin of that. The origin of this is basically effectively an attempt to map an old time approach to how you understand the features of the network into a network that doesn't work that way. And probably not incidentally, but I wouldn't want to impute to anybody, nefarious motives, to make sure that the regulator could still collect the money from the formerly regulated service that is now effectively free. The most obvious example of this, of course, was voice, which was at long distances a tariff service that tended to provide lots of income for in certain places, and suddenly that becomes effectively free. So that's really the point of the linguistic turn, that it turns simple data from end to end into a thing that is regulated. I think that's different from the operational networks that this technology, the vertically integrated effort, is supposed to address. Right? This case is really a kind of control system that really needs precise timings from end to end, and that case is one that is extraordinarily difficult to handle over TCP/IP, although it's possible because we see people doing research over that. So that's the difference between the over-the-top and operational technology, and I just wanted to make sure that the two things were not conflated, because it sounded to me in the question like they might have been.
Great, thanks, Andrew. So we have a question from Mark. Mark, I went ahead and promoted you, so if you want to go ahead and ask your question. Oh, it looks like we lost Mark.
Sorry, I'm just confused. This is Mark. I was just confused by the user experience. Can you hear me now?
Yep, we can hear you. Go ahead.
Okay, yeah. An observation and then a question for Richard. This is Mark Swanzarek from Microsoft, by the way. It seems to me that the Chinese domestic market is very huge, and also that the Chinese national government has a lot of control about the boundaries of the Chinese network, and that they can control what happens within the Chinese national network. I mean, I know there's no such thing, but the internet within China's borders could be substantially controlled by the Chinese government. They could set their own standards. The market is big enough that they could mandate the creation of silicon and the replacement of hardware, etc. I mean, they could have mandated the wholesale adoption of IPv6 if they had been interested in it. So it occurs to me that the Chinese government could simply say these new IP concepts shall be implemented for all Chinese companies, services, government entities, etc., and then force that to exist side by side within China until the technology is mature, all the while working through the ITU to sort of propose the concept to say, look, we are doing the development work here, we are prototyping it, we are doing the proofs of concept, and then during capacity building, the sort of activity that happens within the United Nations, they could say, hey, I have something that is now proven to work. Would you like to do this? For people who don't have a lot of capacity, that would not actually be a wholesale replacement necessarily. It could be brand new infrastructure. And so my question is to Richard, are you seeing an interest within China, either the government or other entities, to take such an approach, to mandate new IP concepts within China and push them forward just simply in isolation within China and see how things go?
I think you've made that point. The question is, is China going to do that? Or do you see any indication China's going to do that?
Right. Thank you, Mark. Thank you for your question. And I think the answer actually is larger, much larger than what I know and larger than my expertise. And mostly I work with European customers, carriers, and companies, and work with them. But I have limited knowledge about that. But even from such limited knowledges, and I never heard that Chinese government actually endorses new IP or not. But just on the contrary, in a public ACM meeting, so I talked with some participants from China. They told me that they are working on IPv6, and they have no idea about new IP. I think even in China, new IP still stays in the private sector, and from the list of customers here, and I have been working with last few years, and all of them are European ones. Thank you.
I would like to follow up on that question. So, as you're probably aware, and it's probably an uncomfortable topic for you, but one of the reasons new IP is so controversial is that it is perceived, within the context of the U.S. attack on Huawei and exclusion of Huawei and the general deterioration of and decoupling of China and the U.S. Internet economies, this is perceived as a move to take over and fundamentally redefine the nature of the Internet. So I think what Mark was describing was a possible pathway in which China might try to do that. And do you see the objectives of new IP as a way to sort of elevate China's role in global Internet governance?
Absolutely not. I see that new IP from the right beginning, it was designed to support industrial applications to serve the European market initially, right? So started in SC, but in SC some opinions are different. One is that extend, improve IP. Another opinion is that let's do something new. That's not an IP. So we divided actually. So we worked together for a few years. So and because from the interaction with European customers, so they prefer the new IP extension for multiple reasons, like investment protection, and also cost reduction, lots of reasons, like expertise, education, many reasons. So I had several meetings with some high-level executives there. So it's motivated by the real problems there. So there. So, and also you know that like industry 4.0, they also need something like this, right? So it has been talked about already a few years. Industrial internet, we have talked about it 10 years. But where is the protocol for the industrial internet? Practically none. So it's and most of they are working on 10 megabit Ethernet. So that's the industrial Ethernet, but it's not industrial internet, right? So talk about that. And I don't see that. And on the other hand, because we have talked about that, that's a FedEx that kind of IP thing there, because new IP will guarantee some latency, packet loss, that kind of thing. Any state actor, no matter who he is or it is, it's very hard for them to control my new IP packet here. The reason is that because I'm going to bring a few more parameters to the internet. Currently, internet, it's called a link state. Link state basically is just one matrix. When you forward the packet out, you look for the shortest path, right? Shortest path. So that's it. After you add more matrix to it, all of a sudden, the control of the internet will be more complex. Scaling is all the issue. So the only solution here is that only decentralize the control. Decentralized control plan, no matter who he is. This technical nature here. As I said earlier, like I never get information, never got any knowledge, like Chinese government is involved here. Like it's so unfortunate actually for me to hear something here. I know some media have cooked some story. For me,
we're trying to get a better, a more accurate depiction of what's going on here. I do have to say one thing. I have direct evidence that the Chinese government was actually ordering everybody to convert to IPv6 as of 2 years ago, and I don't know how successful that has been.
That was true, and I happen to know the one who was responsible for that project like 20 years ago. So he invited me to visit him like 20 years ago. So we talked about that. So that time he worked on IPv6. A couple years ago, I saw him and in an international conference, right? We just told me that. So official position, as far as I know, is still IPv6 there. So new IP still stays in the private sector, and Huawei, of course, involved here, and also multiple European and companies were also involved there. And so here, and then so from the problems we are trying to solve, all of them coming from Europe.
Okay, Andrew, do you want to get in on this?
Well, I think, first of all, it's really important for me to say, and really for the Internet Society as well, to be very clear that we think that multiple vendors, whatever the nationality of their origins and so on, having multiple people working on the development of the network, of the Internet and of other networks, is important. And I don't think that I recognize that some of the froth around this has to do with geopolitics that are way above my pay grade. That said, there is an issue about the proposals as they exist, which have this property that since the network has a lot more of a stake in what happens to various packets that go through it, the regulatory pinch point from the point of view of any government moves from the devices and the applications that are under the control of the user into places where the network gets to interfere. And that's part of the reason that I keep harping on about this question: what are the use cases we're trying to address? If this is the industrial network, there are real questions about how much of that network wants to be exposed to the internet at all. It's not always obvious that we want every industrial network to be hooked up to every other computer in the universe. So that actually has consequences. And then at that point, maybe we've got gateways and so on, and it's a very different kind of network design. But if what we're talking about is a fundamental protocol that is going to replace the low levels or going to live alongside it, or whatever it is that we're saying is going to happen, it's going to be a low-level protocol that's going to be general purpose. and presumably eventually would evolve into the replacement of existing IP and TCP and so on, then it has these very different properties. And if the network has a whole lot more control over what happens to that, that has consequences for the utility of the internet, and it has consequences for the utility of the internet for humans, because it puts the control back in the power of the regulator and away from the edge. And we should be clear about this. There are definitely regulators in the world who do not like the internet because it takes the power away from the network. That is definitely a position that some network regulators don't, they don't talk about it very much, but it's very clear that that's their position. And I think that that's one of the features of the internet that I really like, that the control of the system is really pushed towards the edge, and it's pushed into the hands of people who can do new things with it. That's a piece that I really want to preserve, and it's one of the concerns that I have about some of the proposals that I've seen that are underneath anything we'd call new IP or vertically integrated networks or whatever.
Very good. I think that is a concern that many people share, and however, it's also fair to point out that the Chinese government has done a pretty good job of controlling people and things with the existing protocol, for better or worse. Let's get another question. Is there anybody else, Brendan, who's lining up?
Don't have any more hands raised, but I have a couple of questions from the chat earlier that we could probably combine. So Toralis asks, should the internet not be allowed to provide different services for different traffic? And relatedly, Ian Brown asks, what would new IP add to intserv and diffserv?
So I saw the question from Turles, and I think it was directed at me, so I'll respond to that. Look, the internet already provides differential service to various people. That's a fact of the way it's deployed today, and sometimes that is by accident, and sometimes it's on purpose. But as Laura DeNardis, who I guess has dropped off, did point out, there are already plenty of use cases where you have good performance and latency and jitter commitments about what the network is going to do. And if you are a party to one of those contracts, you spend plenty of your time and effort making sure that your vendor is in fact complying with what they promised you. That's a thing that people do. So that's already an existing feature of the network. The question is more. The question that I would rather want to ask is whether that is a feature that we want to make a permanent part of every network, and whether every network needs to do this, or whether it's a thing that we would want most networks to provide, or something like that. And that is a very different kind of question. And I still can't tell which side of the line we're going to land on that, because that seems to me to be one of the more fundamental pieces of this. Part of the answer as to why I can't tell that is because this is still in the research phases. It's not really a fully worked out protocol, never mind a standard, and so we don't actually know which thing we're doing. And that brings us back to this question of whether comparing a theoretical future thing that hasn't been invented yet to an existing deployed thing with all the hairs all over it is a fair comparison, because it makes it difficult to do comparative analyses between an actually tawdry existing thing that's deployed all over the place with all of the history associated with it, and a magical future technology that we haven't built yet. The magical future always comes off better. Now, I'm not saying that this is a complete fairy tale. Of course it isn't. There's real work underneath this, and I think it's commendable. But I do think it's important for us to recognize that there are consequences to the design choices that are going to be made here, and those consequences have effects on what people can do with this technology that we've managed to invent. Richard was quite correct when he started. This is maybe one of the most powerful technologies people have ever invented, and I think that we want to make sure that we don't lose many of the properties that make it so special.
So let me try to bring things to a close here. I want to begin by saying that the Internet Governance Project is is all about Internet governance, and one of the key issues and my work in particular has highlighted is this issue of the so-called fragmentation of the Internet and whether the Internet was going to break apart. And 3 years ago, I published a book that said, the layer 3 compatibility of IP is so powerful that we will never fragment the internet. But what we do see is what I called alignment, in which nation states try to bring control of the internet align it with their national borders. And we have seen that happening at a pace that even exceeded my expectations, particularly with the Trump administration and their attack on our connectivity to China. So the reason the new IP discussion is so important is that if this decoupling, this division, this separation between China and the US, which of course are the two world's biggest internet economies, if this continues, we very well could be looking at a technical fragmentation of the sort that I said would not happen. If indeed one of the outcomes is that we get different incompatible protocols. So I think that this is a very important issue. I think that we have learned that there are fundamental principle disagreements about design, particularly around the end-to-end argument. But I don't think we can see new IP as an attempt to completely replace the internet. I think Richard is talking about backwards compatibility and about trying to add capabilities. So with that background, let me give each of you a chance to give us a 2 or 3 minute wrap up, starting with Richard.
Right. So it's a very unfortunate idea to fragment the internet, and I don't think it's the right way to go. And personally, as I said earlier, we want to maintain the integrity of the internet. I strongly advocate the internet is one and only one. It should be for everyone, every person, every economy, and every industry. It's for humanity, right? So, and the internet is the engine for our current economic world. Everybody benefits from it, even myself, right? In the last so many years, my job in this industry, I made routers, design routers, software, right? So we should maintain that, no question about that, right? So, and regarding new IP will make something that should not happen and will be very, very difficult to happen, or if not impossible. So why? Because we have some guarantee inside, and if the router knows that, okay, if I deliver this packet to somewhere, I cannot guarantee it that the router will drop it. Sorry, I cannot deliver it. Just when you send a package to FedEx said sorry, we cannot deliver it because it's in the mountain. We don't have airports, right? Same thing there. So new IP make it harder and to do anything that try to interfere with the user rights. If you take a look at the new IP favors user control because the user owns the data, uses the data. So we empower the end user in using the internet. Right? So there are multiple techniques inside. So today is not the venue to talk about that. Hopefully, I can discuss with you and in other IEEE conferences and there. Right? So about there's no doubt. So and Milton also mentioned a vertical industry here. So if suppose we have a box that can be sold to multiple and shared and vertical industries, that will be do good to our economy and industry for cost reduction, productivity enhancement, right? So because something shared, the internet, the reason internet is so successful, actually one thing is that it's shared. Same infrastructure is shared by so many people. The new IP is still the same thing. I think, and also my advice or good word, because the last wrap up for Andrew, because Andrew holds a strong position there. So my advice for you is that and let IETF, ISOC, take over the new IP, standardize it, make it open, and to everyone. So that this technology should not be like just people say new IP in China. I have heard a question here. I understand it, where it comes from, because in ITU is a state sector and industry sector, right? But in order to make proposal, you need to get like a government's like approval. Maybe that's the reason. Every government protects its own company. I understand it, like US and other countries. I know, but as a research scientist like me here, right? So I like fully like promote internet as one. I do not want internet to be fragmented, to be like a manyness. Manyness is a fact. It's emerging partly because internet cannot solve their problems. So if they cannot solve, they define an internet. And also internet so many years, ossification and happening, right? So okay, so time is running up. So hopefully I have more chances to discuss with any of you if you have more questions. Thank you very much.
And I'd like to thank you, Richard, for being so willing to cooperate and participate in this event. Andrew?
Thanks. I also want to express my thanks both to you and to Richard for this conversation. I think it was really good. But I think one of the things that we've discovered today is a sort of very deep question about what it is we think we want out of network technologies. And one of the things that the internet, in its creation, was responding to was this issue that there were all these different kinds of networks that had different sorts of properties and so on. And so you ended up with a very, very thin, very lightweight thing, the IP and then TCP and UDP and some other stuff, that allowed them all to work together and yet do things independently of one another. And this led to a natural sort of, Lego block or whatever sort of architecture in which, various little pieces work together. I think that the concern that you're hearing from me about this is that it's impossible to tell whether what we're talking about right now is going back to that model where we've got sort of intercompatibility but very specific use cases under certain circumstances, or whether this is a common network that goes through everybody's system. And those two cases have very different properties. As I saw somebody say in the chat, it could be that we're heading backwards towards the old switched network from the telephone age. And if that's the case, it's got very different properties than particular use cases that allow those networks to interact in a way that they can provide the guarantees that are necessary for those use cases. I think figuring that out and then figuring out which pieces of these are in fact things that everybody needs is really the critical feature that is still missing in the discussion about this. And if we could get that sorted, we'd be a long way to figuring out which venues we need to be discussing these things in, who needs to work on things, whether this has any implications for IP or doesn't, and so on. I think that gap is the one that I'd really like to see filled.
All right. Again, thank you both, Andrew and Richard, for your articulate presentations and discussion today. And let me just invite the rest of our audience to subscribe to the Internet Governance Project's mailing list, where you get notification of these kinds of events. And bear in mind that we're at Georgia Tech in Atlanta, and we also run educational programs on, we have a master's degree in cybersecurity policy, and you can investigate those possibilities as well. So with that advertisement, I will close the event. And again, thanks all for attending, and we look forward to continuing this conversation.
Thank you very much. Thank you, Milton, Andrew, for very constructive discussions. I hope, like Andrew said, many questions have not been discussed. I hope we have more chances. Thank you very much.
Thanks.